Hello, Chemistry 152 students. I got an experiment here prepared, and it's all about intermolecular forces. And this specifically is from chapter 11 to 11.3 if you're looking for it in the textbook. So, what I wanted to talk about is the strength of intermolecular forces and how that corresponds to surface tension. So, I got three different molecules set up here, and I'm going to kind of tell you how that relates to surface tension. So over here, we have vegetable oil. This is isopropyl alcohol, and then we have water. So these three vary in surface tension and in intermolecular force. There are four types of intermolecular forces. There are dispersion forces, dipole-dipole forces, hydrogen bonding, and then also ion-dipole bonding. Now, this one over here, vegetable oil, only has dispersion force bonding. Isopropyl alcohol has hydrogen bonding, and so does water. Now, the stronger the intermolecular force, the stronger surface tension is going to be. If you want to know what surface tension is, think of it as like an elastic sheet that goes on top of a liquid, and once surface tension is broken, the whole liquid like spews around. So think about it like that. So this obviously has the weakest one, but these two both have hydrogen bonding, and so that might make you confused on why this one has less than this. Well, this is because isopropyl alcohol only has one OH bond, as opposed to this one that has two different ones. So that kind of shows it's more strong because it has more hydrogen and oxygen bonding. That's how that works. All right, so here's everything that you're going to need to do this experiment for intermolecular forces. So what I got here is I got these disposable pipettes. I already put them in the liquids. I got all three of these molecules here. We got vegetable oil, we got isopropyl alcohol, and we have water in this cup. Of course, we got to demonstrate proper safety. So wear your gloves, and also wear your goggles. Any experiment you do. We also have pennies here, and this is what we're gonna do. So we're gonna take these disposable pipettes, we're gonna grab these liquids and put them on the pennies. It's gonna keep going on top of the pennies until it bubbles over and falls over. Because of surface tension, it's gonna bubble on the top, and then eventually when that elastic sheet, that surface tension breaks, the liquid's gonna pour out and fall onto the plate. So we should be seeing a trend of the oil having the least amount of drops and then going up from here. And I put a little thing down there so we can measure how many drops we have. I also have these paper towels. You don't really need them either, just to clean off the pennies if you only have like one or two. All right, now that's all you're gonna need. Oh, and a plate too. Make sure you have some kind of ground you can put the pennies on and just using a plate. All right, we're gonna do the experiment now. So take one of your pennies. If you have multiple, that'd be nice. Don't have to. Now remember, use them on the same side. Use it always on the same side. I'm choosing Lincoln. So we're gonna start with the oil, and we're gonna measure how many drops we have. So use your disposable pipette. I'm gonna grab as much as you can in here. Alrighty. We're gonna count how many drops we have here. 1, 2, 3, 4, 5, 6, 7. Now here's something to note. The whole penny is covered here. I think where we at? 6, 7, all right, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, wow, 17, uh-oh, here we go. Oh, 18, 19, 20, there we go. All right, so 20 to 19 is our range now in the surface tension. So we're gonna mark that down. Pretty sure it was 20, might be 19. We're gonna go a safe 19 here, 19 to 20, between that range. Okay. Now you can always just wash the penny with water and soap if you'd like, or we could just kind of just use a new one here. Make sure you keep track of which one is which. So we're gonna use this one now. And now we're gonna do the isopropyl alcohol. So this one should have more than 19 and 20. This one should have more, that's the goal. All right, here we go. Let's start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, we beat the last record. 21, 22, oh, 23, 24, 25, 26. Oh, here we go. All right. 25 to 26 seems to be our range on the isopropyl alcohol. That's good. We wanted to see a higher number, so we'll put 25, 26 over here. All right, the last one. Once again, you can rewash your pennies if you'd like. I'm just gonna use a brand new one here. Oops, sorry. All right, and then here's gonna be the last one, and we're gonna use the water on this one. So this one should have the most, because remember, this has the strongest hydrogen bond and the strongest intermolecular force. All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Look at that bubble on there, that surface tension. We're at 30, so 31, 32, oops. 33, 34, 35, 36, 37, 38, 39, 40, I think. 41, wow. 42, 43, 44. Oh, there we go. Okay, 43 to 44 is our range. You can kind of see that surface tension bubbling on the top of that one a lot, because that one has the strongest intermolecular force. So here's our range we got here. If you go ahead and test this, you can see if you get similar numbers to me on these. If you'd like to do the experiment yourself, a couple notes to make. One, make sure you have either different pennies or wash each one to make sure there's no residue on them. Number two, put them in containers like this, whatever you want to do for that, to store the liquids. It's easier that way. Another thing you could do too, if you want to change up the experiment, make it a little bit different, you could try other liquids and see how they react, how much surface tension they have. We only use dispersion forces. You could try a liquid that has dipole-dipole. You could try that. You could try a bunch of different other liquids to see how much it can hold on the penny. Something else you could test out is different coins, see if different coins can hold different amounts, even if the same liquid. You could try temperature. See how much temperature ranges, how temperature difference with the same liquid. That's something interesting you could try. And that's kind of about it for my experiment. Thank you for watching.